going to move on to our fourth case. Our fourth case is very closely related to our third case because, well, the fourth case is finding the angle between two vectors. So if we have two position vectors here, A and B as usual on our beautiful IJ graph, and this is our position vector A, and this is our position vector B, then the angle between them is going to be this angle theta. Now, in the previous case, we were trying to find in the previous case we were trying to find what we call the product between them, the dot product. Now, when we did that, we said that the rule states that product rule, just so you know what we're talking about. So what we said is that we need to multiply the magnitudes of A and the magnitudes of B by the angle between them in order to get the product between the two vectors. Now, what this case actually wants is that it wants this angle. So what you're going to do is just rearrange to get theta, or cosine theta, equals to the product of AB divided by the magnitude of the products of A and B. And after that, you can just do on your calculators shift cosine of that in order to get the exact value of theta. An important thing you need to know though about this theta is the following. First of all, this gives you, let me get a red color, this gives you the acute angle between the vectors. So it technically gives you the theta on the graph. If you want this angle instead, you have to do 360 minus. It depends on what the question asks for, but it's usually the acute angle, and this is how you do it. So the fourth case is very simple and straightforward, which means we can move on quickly to our fifth case. Now, our fifth case relates to one of our properties because it's about parallel vectors. So how to determine if two vectors are parallel or not. If two vectors are parallel. The condition for this part is to use case 3 and 4 technically again, is that we're going to be using the dot product. Now, how does the dot product or case 3 and 5 come in handy? Let us just, case 3 and 4. Let us write case 4 again. So, we're talking about the product rule here, and when we stated it, when we made the angle the subject of the formula, we said that cosine theta equals to the product of the two vectors divided by the product of their magnitudes. Now, if and only if the two vectors here are parallel, so we're talking about the vector A here and the vector B there, if they're parallel, the angle between them, so let's say let's draw them on the same line. Let me use another color, so green. Yeah, if we say this is A and then we say this is B, then the angle between them, theta, equals to 0. And if theta equals to 0, so this is going to be cosine 0, which is in this case equals to 1. So if you want to determine if two vectors are actually parallel, you need to multiply them by each other and multiply their magnitudes, and that way you're going to get the cosine of their angle. In other words, you know that it's going to give you cosine 0 equals to 1. In other words, this means that this vector is supposed to equal to the magnitude. So and another thing is, parallel vectors can also have an angle of 180 between them. So if we're comparing A here, and instead of B we're doing negative B, so we're going like this. Again, we know that these two are still parallel, but with the lambda being negative. And if they're parallel, This means also that their cosine, and their cosine here is going to be of 180, and it's also equals to 1. So it's still going to give you the cosine equals to cosine 0 or cosine 180 equal to 1. So if A and B are parallel, so this makes this rule apply, which is that the multiplication of the two vectors is going to equal to the product between their magnitudes. And that would be it. So that would be it for the how to determine if two vectors are parallel. You're just looking at their cosine, their angle between them, which is 0 or 180, and you're trying to prove that their product is going to equal the product of their magnitudes. Now that we are done with this part 2, we can move on to our next case, which is determining whether two vectors are perpendicular. I'm gonna follow up this in this video because it's very closely related to parallel vectors. So vectors are perpendicular or not. Again, we're going to graph here our ij graph, and we're going to draw two parallel vectors, two perpendicular vectors. So we have this vector here a and this vector here b, and this is our vector a. And yes, how to determine if they're perpendicular? If they're perpendicular, what we know is that this is going to be a right angle. So if we want to write the product rule here, the dot product rule, we are going to say that cosine theta is going to be the product of both vectors divided by the product between their magnitudes, and we know that theta here is 90, so it's going to be cosine 90, which is also equal to 0. And this means that this would mean that the product between them it has to equal to 0, because this is going to be 0 multiplying this by this, so the product between them is going to be 0. So if two vectors a and b are perpendicular, the angle between them is 90. Because cosine 90 is equal to 0, then the product between ab is going to be equal to the product of their magnitude times cosine 90, which is 0, which is going to eventually give you 0. And that would be the sixth case, and we're done with the angle parts.